Hi everyone, welcome to AI Crack channel. This is Akash Gangwar and today we'll be studying progressions lecture 4. In this lecture we'll be continuing with AGP and also we'll start with different types of means. Okay. So let's begin our lecture with the summation of AGP. In the previous lecture we talked about what is the general term for AGP, right? In this lecture we'll be talking about how to solve the summation of AGP, right? So let's denote the summation as S. The first term is A, second term is A plus D multiplied by R. Third term is a plus 2d multiplied by r square. Fourth term is a plus 3d multiplied by r cube. And the nth term would be a plus n minus 1d multiplied by r is by n minus 1, right? Now the standard way to solve this one is to multiply the common ratio in the entire series and then subtract the outcome from this particular equation. So let's say this is the equation 1. Let's multiply r, that is the common ratio in the entire series. Okay. So we'll be getting r times s. That would be, let's write ar over here. So when we are multiplying r in this first term, let's write that term over here. Basically shifting the entire series, every single term by one position towards the right. Okay. Now the second term would be a plus d multiplied by r square. Third term would be a plus 2d multiplied by r cube. N minus 1th term would be a plus n minus 2d multiplied by r square minus 1. And the last term would be a plus n minus 1d multiplied by r square n. Okay. Now we have to subtract both of them. So we'll be getting s times 1 minus r equals to, this would stay as it is because we don't have a corresponding pair over here, right? Plus, if we subtract this from this, what we'll be getting? We'll be getting dr, right? Over here, we'll be subtracting this from this, and what we'll be getting? We'll be getting dr square. Over here, we'll be getting dr cube. And similarly, for this n minus 1 term, we'll be getting dr is per n minus 1. And last term would be this one, that is a plus n minus 1 d multiplied by a is per r is per n, right? This would stay as it is because we don't have a corresponding pair over here. We have corresponding pairs for these many terms, that is n minus 1 terms. We don't have a corresponding pair for this one and we don't have a corresponding pair for this one. So these two terms would stay as it is. Okay. Now this is a standard GP, right? With first term as dr, common ratio as r, right? First term as dr and common ratio as r. And we have n minus 1 terms. Why? Because this is the first term. Overall, we have n terms over here. So this much is having n minus 1 terms, right? So we have subtracted. Basically, we have subtracted these corresponding pairs with each other. And that are n minus 1 terms. So this is n minus 1 terms. Okay. This is one additional term. This is one additional term. So total we have n plus 1 terms. Now to solve this, what we have to do, we have to first solve this GP and then add this one and subtract this one, and then we'll get the answer. Okay. And now let's solve the example to understand more about how to solve summation of AGP. Okay. So over here we have 10 is per 9 plus 2 dot 11 dot 10 is per 8 plus 3 dot 11 square dot 10 is per 7 and so on. And we have to find out the value of k. Okay. Now over here we can see that this first term and last term, they're not in the standard format. Standard format looks like this one. But these first and last term, they're not in the standard format, right? So we have to first convert them into standard format, right? So let's say we have the summation as s, that is equals to, let's write the first term in the standard format. That would give us 1 dot 11 is per 0 dot 10 is per 9. Same thing, right? Now second term would be 2 dot 11 is per 1 dot 10 is per 8. Third term would be 3 dot 11 square dot 10 is per 7. And the last term would be 10 dot 11 is per 9 dot 10 is per 0, right? Now that we have written this in the standard format, we have to multiply with r, that is common ratio. How to find out common ratio over here? That would be this divided by this. Okay. So that would be 11 is per 1 dot 10 is per 8 divided by 11 is per 0 dot 10 is per 9. And that comes out to be 11 by 10. So common ratio over here is 11 by 10. So let's multiply 11 by 10 in the entire equation. So that would give us s into 11 by 10. That would be, first term would become, writing the first term over here, that would become 1 dot 11 is per 1 dot 10 is per 8. Second term would become multiplying basically 11 by 10 in this term. That would give us 2 dot 11 square dot 10 is per 7. N minus 1 term, basically ninth term would be 9 dot 11 is per 9 dot 10 is power 0, and the last term would be 10 dot 11 is power 10 dot 10 is power minus 1. Now this and this gets cancelled out, right? Now we subtract both of them, we'll be getting minus s by 10, right? When we subtract this from this one from this one, we'll be getting minus s by 10. Now that comes out to be, this is alone, right? This is not having any pair, so that would be 10 is power 9 only, right? Now this becomes 11 is power 1 dot 10 is power 8. Now this becomes 11 square dot 10 is power 7. This becomes 11 raised power 9 dot 10 raised power 0, and this itself is minus 11 raised power 10. Okay, and now we know that this is a standard GP. Let's first find out the summation of this particular GP, right? So over here, this is the first term. Common ratio is 11 by 10, right? Common ratio is 11 by 10. This is the first term, and number of terms equals to 9, right? So let's find out the summation, that is S dash. So S dash comes out to be first term, that is 11 raised power 1 dot 10 raised power 8 multiplied by R, that is 11 by 10 raised power 9 minus 1 divided by 11 by 10 minus 1, right? This is the S dash. Now this can be written as 11 dot 10 raised power 8 multiplied by 11 raised power 9 minus 10 raised power 9 divided by 10 raised power 9 whole divided by 1 upon 10, right? Now this goes over here, it becomes 10 power 9, and this gets cancelled out, right? So what we have got eventually, we have got S dash as 11 raised power 10 minus 11 dot 10 raised power 9, right? So this is our S dash. Now we want to find out the value of minus S by 10, right? Now minus S by 10 is nothing but 10 raised power 9 plus 11 raised power 10 minus 11 dot 10 raised power 9 and minus 11 raised power 10. Okay, now this and this gets cancelled out. What we have got, 10 raised power 9 minus 11 dot 10 raised power 9. Now this becomes minus 10 dot 10 raised power 9. Okay, this is our minus S by 10. So S would be 10 square dot 10 raised power 9, that is 10 raised power 11. Okay, now we have to find this k dot 10 raised power 9, right? So over here k would be 100. Okay, so you can back check the calculations, might have made a mistake over here in the calculations because it's a long process, but overall you have to solve it like this only. Okay, and now let's talk about AM, GM, HM for two numbers, that is arithmetic mean, geometric mean, and harmonic mean for two numbers. So let's say the two numbers are A and B, small a and small b, right? And firstly we have to find out arithmetic mean. Let's represent that as A, right? So A is defined as small a plus b, small b divided by 2. Basically capital A is defined as small a plus small b by 2. Okay, now the interesting part about this capital A is this small a, capital A, and small b, they all are in AP. Okay, so we can write capital A minus A equals to B minus capital A. Okay, so this is valid because these three actually are in AP. Okay, and now let's talk about the second one, that is GM, geometric mean. Let's represent that by capital G. Okay, now this is defined as under root of AB. Now here's one important thing over here. If A and B are both positive, G would be under root AB, simple. If A and B are both negative, in that case, G would be minus of under root AB. Okay, because it doesn't make sense to have a mean, any kind of mean between two negative numbers as positive, right? So if you're just writing G as under root AB when both A and B are negative, in that case that would be a positive term between two negative terms. That doesn't make any practical sense, right? It's a mean, it's a kind of mean, it has to be in between A and B, right? So in that case, when A and B are negative, it has to be minus of root AB. Okay, that's one thing. Secondly, A and B both have to be either positive or negative. It shouldn't be like A is positive or B is negative, B is positive, A is negative. It shouldn't be like that. Why? Because in that case, we'll not get the real value of G. We'll get a complex value of G, right? And that's not possible. We cannot fit a complex mean between two numbers, two real numbers. That's not possible, right? So that's why A and B either have to be positive or they both have to be negative, right? And the first case was G is equals to root AB for when A and B are positive, G equals to minus root of AB for when A and B are both negative, right? And now let's define the last one, that is harmonic mean. Okay, let's denote that as capital H. Now when we are saying A and B are in harmonic progressions, in that case what we actually mean, we mean that 1 by A and 1 by B are in AP, right? This is how harmonic progressions are defined, right? If A and B are in HP, can simply say that 1 by A and 1 by B are in AP, right? So let's say we have this term 1 by capital H over here, that is representing the mean over here, right? For this AP, 1 by H is the mean, arithmetic mean, right? So 1 by H, that would be 1 upon A plus 1 upon B by 2, right? But for this one, A and B, that would be capital H, right? That would be harmonic mean. If 1 by H is the arithmetic mean for 1 by A and 1 by B, capital H would be harmonic mean for A and B, right? Simple. So 1 by H comes out to be this. So H becomes 2 upon 1 upon A plus 1 upon B, right? And now to summarize this, we have got AM equals to A plus B by 2, right? GM equals to under root AB, given that A and B are positive, and HM equals to 2 upon 1 upon A plus 1 upon B. That comes out to be 2AB upon A plus B, right? So these three are AM, GM, and HM. And we know that for two numbers, these three are related by this identity, okay? G square equals to AH. And now let's solve this example. The AM between two positive numbers exceeds their GM by 5 and GM exceeds their HM by 4, then find the numbers. So let's say the numbers are A comma B. The positive numbers are A comma B, right? Now the first equation says AM between two positive numbers exceeds their GM by 5. So basically that means A plus B by 2 minus root AB, that is GM, equals to 5. Basically AM exceeding GM by 5, right? That is our first equation. Now second equation would be GM, that is root AB minus HM, that is 2AB upon A plus B equals to 4. This is our second equation. Now we can see that root AB is not a very desirable term in the given framework of equations, right? Because it's very difficult to solve A plus B along with root AB, right? It's very difficult. So that's why we have to first eliminate that term. So we can see that we can use the root AB value over here, right? So root AB would become 2AB upon A plus B plus 4 from second equation, right? Root AB equals to 2AB upon A plus B plus 4, right? Now we have to utilize this value over here. We'll be getting A plus B by 2 minus root AB, that is 2AB upon A plus B plus 4 equals to 5, right? Now on further simplifying, we'll be getting A plus B by 2 minus 2AB upon A plus B minus 4, and we can take this 5 over here. We'll be getting minus 9 equals to 0. So this becomes A plus B whole square minus 4AB minus 18 times A plus B equals to 0. Okay. Now over here we have A plus B whole square, we have AB, and we have A plus B type of term. We have these three types of terms: A plus B whole square, AB, and A plus B. And to make it more solvable, we have to eliminate at least A plus B whole square, right? So where do we get A plus B whole square? We can get it from first equation. So our first equation is A plus B by 2 minus root AB equals to 5. On further simplifying, we'll be getting A plus B by 2 minus 5 equals to root AB, right? Because if we are squaring, we don't want A plus B and root AB to be clubbed together, right? So that becomes A plus B minus 10 equals to 2 root AB, right? 2 root AB, sorry. On squaring on both sides, we'll be getting A plus B whole square plus 10 square minus 20 times A plus B equals to 4AB, right? Now we have got A plus B whole square, we have got A plus B over here, and we have got AB, right? Now we can use this equation to replace the value of A plus B whole square. So A plus B whole square equals to 4AB plus 18 times A plus B, right? So using this one over here, we'll be getting 4AB plus 18 times A plus B plus 10 square, that is 100, minus 20 times A plus B equals to 4AB. Now this and this gets cancelled out. What we have got? We have got 2 times A plus B equals to 100, right? And that gives us A plus B equals to 50. And now we have got A plus B as 50. We can plug this value over here. So we have got 50 minus 10 equals to 2 times root AB. Now this becomes 40, this becomes 20. So we have got root AB as 20 and basically AB as 400. Now if you can use common sense, in that case, A is 10, B is 40, or vice versa. A is 40 or B is 10. Or you can form the quadratic equation over here and then you'll get the same values, right? Either way it's possible. Now let's solve this example. If a, b and c are distinct positive integers less than or equal to 10, the arithmetic mean between a and b is 9, geometric mean between a and c is 6 root 2, then the harmonic mean of b and c is, okay? So the three distinct positive integers are a, b and c, right? Now let's talk about the first case. We have a plus b by 2 equals to 9, right? So that basically means a plus b equals to 18, right? Now we know that all of them are distinct positive integers which are less than or equal to 10, right? So a can be 10 and b equals to 8. That is one case, right? Second case can be a equals to 8, b equals to 10, right? That's one more possibility. Can we say that a equals to 7 and b equals to 11? No, we cannot do that because we know that all of them are less than or equal to 10. So that's not possible. Can we say a equals to 9 and b equals to 9? Can we have this kind of case? No, we cannot have because all of them are distinct. So that's also not possible. So what we have got these two cases, a equals to 10, b equals to 8, or a equals to 8, b equals to 10, right? Now let's talk about the second condition. Geometric mean between a and c is 6 root 2. That basically means under root ac equals to 6 root 2. We square them, we'll be getting ac equals to 72, right? Now if we take the first case, a equals to 10 over here, we'll be getting 10 dot c equals to 72. That basically means c equals to 7.2. That's not possible because we have to have integral values, right? So that's not possible. Now if we take the other case, second case, basically a equals to 8, we'll be getting ac equals to 72. That basically means 8 dot c equals to 72. That gives us c as 9, right? So we have got an integral value of c from here, so that's an acceptable case, right? Now we have to find the harmonic mean between b and c, okay? So that would be 2bc upon b plus c, right? Now 2 into b is actually, b is 10, c is 9, right? Divided by b plus c, that would be 10 plus 9, that is 19. So that gives us 180 upon 19. You can again back check the calculations, right? Now let's talk about AM, GM, HM for n numbers. We won't be deriving it, but we'll be extrapolating what we have done for two numbers, right? So let's say we have n numbers, A1, A2, A3 till AN, right? So AM would be A1 plus A2 plus A3 till AN divided by n. GM would be A1 dot A2 dot A3 dot A4 dot till AN raised to power 1 by n. And HM would be n upon 1 upon A plus 1 upon, 1 upon A1, 1 upon A2 plus 1 upon A3 plus 1 upon A4 and so on, 1 upon AN, right? So AM, GM and HM for n numbers are defined like this, okay? You have to remember this. So this lecture was till here only, and in the next lecture we'll be talking about AM, GM and HM inequalities, and also we'll be solving some miscellaneous series, okay? So let's meet in the next lecture. Thanks for watching.